Hello YouTubers! Today I have a small project for you. So I want to make a tool in order to rebuild the crankshafts. Basically small moped or small engine ones. So the tool will help me to press down crankshaft halves so they won't have like misalignment. This is one thing. I want to get close to finish result when pressing it down. So for that project I will use really thick 12 millimeters steel plate. 12 millimeters is the thickness and it's 200 by 200 mils. I will need 5 of guides. They are 30 mils of diameter and 7 centimeters of length. So basically the idea is that I will explain it on the paper. So there will be 20 millimeters of hole in the center. So the hole is dependent on the crankshaft size. So this is currently 17 mils, but I want to use maybe 20 millimeters. So this will be approximately 21 millimeters. Then there will be like 5 pins or guides. And these will be machined. And I will use M8 bolts to lock it on the plate. And I will use fly cutter because the steel plates are not very accurate. Otherwise I get alignment this way. So the bottom end will be larger and the top end will be smaller. So I want to get it as accurate as possible. And yeah, basically this is the tool I will use in the later videos. So it will, but yeah, let's get going. So I will mark down the center. Verify the results. Is it 72? Yeah. 72. Looks good. Okay, the parts are machined now, but I would like to add slight taper on this part because it will make things much easier. And if I press down the crank halves, so it will start much better. So so the angle will be 3 degrees. Okay, parts are ready now, so let's start putting it together. So these are the M8 pitch which I tapped, standard, but bolts are higher grade, so they are stronger. And we have 5 of machined parts out of 30 millimeters round bar. And yeah, so basically assembly is pretty easy. Just I won't tighten at maximum, but at first I thought I will, machine the surface, but I checked with ruler and I didn't see any flatness issues, so at this stage I won't use the fly cutter to smooth it up and having much better finish, but it looks okay, so let's start with that. Okay, from upside it looks like that, so you can adjust the opening with eccentric big balls. So if you have smaller diameter of crankshaft, you will turn them inwards. If you have larger one, you will just turn it outwards. So that's the idea. You can, it's quite universal that way. And to show it how it will look if I'm going to use it in future, you will hear. Imagine these parts are taken apart, and so if you will press down this crank half on the crank pin. So basically you have this single web on the bottom. You will lock the crank. got it a bit tight, so let's undo it. Look this one. Look this one. And start pushing these. So basically, if you look at from that angle, this part is, if you press down on crank pin, so you can't misalign this weak way, so you don't have to do the hammering in order to, fix the issues with the alignment, or basically crankshaft halves are that way. So this will help a lot. So basically it will give me very close result when I'm pressing the crank pin down, so on the crank web. So it's really solid, so I can like take the whole plate and take it up, no issues. So the final product is ready. So it looks like that. So if somebody wants to recreate this, I have no issue with that. So I will just show you a quick plan. So it's 20 centimeters and 20 centimeters that way. So it's 200 millimeters. 200 millimeters. So the center hole, it really depends on the crankshafts you are rebuilding, but it's up to you. Small engines mostly 50 cc have like in maximum of 25, but mostly 70 or 20 millimeters shafts like Derby or AM6. So I machine it 25 mils. Then 5 holes. So they are tapped with M8 and the pitch is 1.25 millimeters. And the distance from the center is 56 millimeters. And of course, if you divide 360 with 5, you get angle of 72 degrees. So the bolts, I used the strong bolts. So basically they're 70 millimeters. They are 10.90 grade. So if you want to use it, $70 mils. The bar, this is basically, it's 30 mils. It's like H9 tolerance, but just needs to be the same diameter. So basically they are 30 mils. No, length is up to 70, but again, it really depends how long how wide the crankshaft is. So if you look at that way, that's more than enough to me. So I can even use wider cranks if needed. So in order to get the crankshafts going, if you press them down, I added 3 degrees of taper, and it's 2 millimeters. So if it's 30, it's 28 from this end. And in order to adjust these 5 30 millimeters steel bars, so it's about 7 to 8 millimeters out of center. So it looks like that. You have this white machined area, and 56. So in total, it's 112 millimeters. So basically, that's it. You will probably see this tool in later videos if I start making racing moped engine. But for now, thank you for watching.